In question 8, the equation of a curve is y equals to 2x plus 1 upon 2x plus 1 for x greater than negative half. We have to find dy dx and d square y upon dx squared. So if we have to find the dy dx, we'll first bring the variable that is in the denominator and bring it in the numerator and write it as 2x plus 1 to the power minus 1. Now finding the dy dx. So differentiating 2x, that will become a 2. Differentiating 1, that will become a 0. And differentiating this bracket over here, so the minus will multiply by the coefficient, so that will become a minus into 2x plus 1. The power will decrease by 1, so that will become a minus 2. And we'll also multiply it with the derivative of 2x plus 1, which is positive 2. So the dy dx will be is equals to 2 minus 2 into 2x plus 1 to the power minus 2. Once we have the dy dx, to find the double derivative or d square y upon dx squared, we'll differentiate this again. So this will become, the derivative of 2 will become a 0. Minus 2 times minus 2 will become a plus 4 into 2x plus 1. The power will again decrease by 1, so that will become a minus 3. And we'll multiply it with the derivative of 2x plus 1. So finally, this answer will be 8 into 2x plus 1 to the power minus 3, or we can also write it as 8 upon 2x plus 1 whole cube. In part B, it says find the coordinates of the stationary point and determine the nature of the stationary point. Now, when it is a stationary point, it means that dy dx will be equals to 0. We already have an expression for dy dx, which was 2 minus 2 into 2x plus 1 to the power minus 2. So as the dy dx was 2 minus, well, it was 2 minus 2 into 2x plus 1 to the power minus 2. We'll put it equals to 0. Now to simplify this, we can take this on the right hand side to make it positive and bring the 2x plus 1 in the denominator. So that will become 2x plus 1 whole squared. Taking 2x plus 1 whole squared on the left hand side, we'll get 2x plus 1 whole squared is equals to 2 upon 2. And this will cancel out. So 2x plus 1 will be is equals to 1. And this is a whole squared. Now taking the square root on both the sides. So taking the square root of 1, we'll get plus minus 1. So this will become 2x plus 1. And that will be equals to positive 1. And as it is a square root, so it can be a minus 1 as well. So 2x will be is equals to, if we take the value of x as positive, so this will become x is 1 minus 1. So x will be equals to 0 upon 2, which will be 0. And if we take the negative value as well, so that will become 2x plus 1. And that will be equals to negative 1. So 2x will be is equals to minus 1 minus 1. And x will be is equals to minus 2 upon 2, which is minus 1. Now over here, as it said that x has to be greater than minus 1 upon 2, it means that we will not be able to take this value of x, which is minus 1, as x is greater than minus 1 upon 2 and minus 1 is less than 1 upon 2. So now once we have the value of x over here, as we have to find the coordinates, now we can find the y value as well by substituting this value of x in the equation of the curve. So the equation of the curve was given as y is equals to 2x plus 1 plus 1 upon 2x plus 1. So substituting 0 over here, we'll get 0 plus 1 plus 1 upon 0 plus 1. So the y coordinate will be is equals to 2, as this will become y is equals to 1 plus 1 upon 1. So the coordinates of the stationary point are 0, 2. And to find the nature of the stationary point, we will substitute this x value 0 into the double derivative. So the double derivative that we got in the previous part was, so that was equals to 8 upon 2x plus 1 whole cube. Substituting x equals to 0 over here, so that will become 8 divided by 0 plus 1 whole cube, which is 8 upon 1. As 8 is greater than 0, it means that it will be a minimum point.